Welcome back, and if you're new to the channel, thanks for watching. I've been researching and preparing for a while now to bring you a fairly comprehensive walkthrough of a cooling system refresh for the A4 B7. We'll be doing some pretty basic maintenance procedures and replacements, but also tackling some failure-prone items on the car. Just as a project summary for now, what we'll be doing is draining the coolant followed by a system cleaning, then probably a rinse, and then we'll get into the work of doing the coolant temperature sensor, thermostat assembly, rear coolant flange, water pump, accessory belt and related components, probably another rinse after that, and then we'll finish up by filling the system, and I'm going to try out the Schwaben air purge fill tool, or as they call it, the evacuation tool. I'm not doing this work for fun though. I'm here because of a fault code, P2181, the performance malfunctioning cooling system fault code. For other VAG cars, you'll actually find that code right there as 18613. This all came about in a pretty normal way. I was driving under very normal city driving conditions, and all of a sudden the mill lamp came on my dash. Luckily, I actually had my computer with me, and I plugged in the Rostec VCDS cable, and this is what I found. A piece of interesting info is right here. The freeze frame indicates that the temperature dropped to 74 degrees Celsius when the error occurred. This video really is about doing the work and not about diagnostics, so I'll just address the fact that this is a pretty general code, and although the Rostec website has a bunch of really great diagnostic information on it, there are a bunch of other codes that can happen as part of the cooling system faults that are related to the electronics or the function of other parts in the system, specifically like the coolant temperature sensor, the thermostat, the water pump. So this one is a bit of a catch-all, but I'm already resigned to doing this work anyways. I can tell by my service records that this car's never received a new thermostat or coolant flange, so this is work I want to do. Nonetheless, the reason I showed you the freeze frame earlier was this. So 80 degrees to 110 degrees Celsius is typically the coolant temperature range that the ECM wants to see while the car is in operating temperature. So even though I don't recall the B7 having any issues warming up, nor was it overheating, it looks like the thermostat might be the culprit here. Just to set the stage, I do have the car up in jack stands right now, which is not totally necessary, although you will need to have access to underneath the front of the car. And I have the front bumper off, and if you don't know how to do that, see this video right here. And I have the front lock carrier out in Audi Service Position, and if you don't know how to do that, see this video right here. And I've taken the headlights out totally on my own volition, but that's not necessary. Just know that you don't have to take off the front bumper or do Audi Service Position unless you're taking out your water pump. First up, we're going to drain the coolant, and by the way, the Haynes manual says that the coolant should be replaced every 5 years, no matter what. With the engine cool, first take off the expansion cap so that the coolant can drain faster. Note that this isn't just a cap, although it is meant to seal the system. This is spring-loaded, so it's supposed to raise the boiling point of the coolant, but then also release vacuum pressure when the system's cooling off. Check the cap for any wear, and do a pressure test on the system if you think the cap may not be holding or releasing pressure properly. If you ever notice a collapsed coolant hose when the system is cooling down, that may mean that vacuum is not being released. So to drain the coolant, you can see that on the 2-liter turbo, there's a drain valve that's connected to a fitting on the lower coolant hose. Now under the car, you can see that when the valve is turned, the coolant will come out of this hole right here. All I've done is put a flexible tube on here and I'll drain the coolant into a bucket. I've disconnected this part of the piping because I want to show you the construction of the inner part of this drain valve. An issue that people encounter quite often is that the drain valve on the outside will rotate 90 degrees towards the front of the car quite freely, and then it'll stop. At that point, people feel that there's nothing draining out and that there's something wrong. Now that I've rotated the drain valve 90 degrees, you'll see on the inside the threading actually takes a little bump. There's a plateau there that you need to pass, and that's why you're feeling resistance. What you actually need to do to get the drain valve to start draining coolant is turn this another 180 degrees for about 270 degrees of total rotation. The coolant is drained, but note that you're only going to get about 2 to 3 liters out of here for now. With the thermostat closed and the engine cool, without applying any other pressure into the system, it's not going to drain the full amount. In fact, you'll only get out less than half. If at this point your goal is to just get as much coolant out of the system as possible, you're going to need to take off another part. That may end up being the water pump down low in the front near the timing belt or the thermostat assembly. Either way, a lot of coolant will drain out if you take those off. Here's a bit of that first drain. Not quite as fluorescent as the camera does justice, I'm sure, but I'll take more samples along the way. We'll see how many times it takes of a rinsing cycle to get it all the way clear, and then we'll take a sample of the cleaning cycle to see if it gets any bigger pieces out, and then I'll have a sample of the final mix with coolant. Now that my partial drain is complete, before I do the cleaning cycle, because I don't really know what's going on with my cooling error, and it could be something to do with the thermostat being stuck in some fashion, I want to make sure I actually do have access to all the different parts of the cooling system, so I'm going to do a series of rinses. The process for these repeated rinses is pretty simple. All I'll do is fill the expansion tank with distilled water, and then I'll go into the car and turn it on, turn the heat on high, but the fan on low. And that'll do two things. One is open up the circuit into the heater core to include that part, but it won't draw too much heat off the engine because I do want it to warm up. Because the thermostat will get warm, open up, and then the water that I just put into the expansion part of the system will get sucked in through the block, and then into the radiator through the top hose here, and then down out the bottom. I'll know the rinse cycle is complete when the upper radiator hose is warm, and then the expansion tank starts taking on the color of the coolant in the rest of the system. I want to get sciencey for a second and talk about water that we're going to be using in these processes. I think it's widely understood that when you're doing the coolant fill, you know you're going to have to mix your coolant with distilled water. But when it comes to general flushes, you'll see from a lot of companies and on the internet that people say using tap water or hose water to push water through the system just to get the old garbage out is totally okay. I'll leave it up to you to decide what you want to do, but my preference is to never put any kind of mineralized water into the system, no matter what the process is. Considering how cheap it is to buy distilled water, and this 4-liter jug that you're looking at is less than $2 from where I come from, there's almost no reason not to do it. This water is also ozonated, and you'll often find that on distilled water labels, and that just means that ozone was added to the water, and that's something that usually keeps the taste neutral and any smells out of the water, but also inhibits any microbiological growth. As a loose definition, distilled water just means that water's been boiled, and while the water's evaporating, that steam is captured into what you see here, but all the impurities that were in the original water are left behind in whatever vessel the water was boiled in. Okay, I just turned off the car a couple minutes ago. It's cooling down now. The temperature gauge on the dash got to low or mid 70s before the upper radiator hose got warm, and as you can tell by the expansion tank color, the coolant that was in the rest of the system mixed in, and now it's pink, so I'm going to do a drain. Now adding to our collection, the first rinse is markedly better than the old stuff. I still think it's going to take another 2 or 3 rinses to come clear. After that drain, I closed the valve and then refilled with distilled water, and I've actually just finished the second cycle now. This one was a bit odd in the sense that the temperature gauge was stuck at the absolute minimum for a long time, even though I could tell the engine was warmed up, and then I had to toggle on and off the heater a few times, and finally that kicked in. I gave it some revs for a while, about 1500 RPM, and then I could tell that it was starting to suck water down, and it didn't go past operating temperature. I was ready for it. I was going to turn off the car if it did, but it never went above, and everything started cycling. The top radiator hose got warm, and I can tell that it's completed a full cycle now. That cycle is drained, and now we can see in rinse number 2 sample, things are looking quite a bit better. The third cycle just finished, and the engine's cooling down. This was another kind of weird one to monitor. The temperature really didn't want to get past about 70 degrees, and I had to coax it up a little higher to get the thermostat to open by revving and keeping the heater on, then off, and then changing the fan speed. Eventually started sucking down the water and everything was working, but this one never did reach operating temperature. As you can tell, the difference between the last rinse and this one is pretty negligible, so I feel like we're at the point of diminishing returns, and I'm not going to do any more rinses, so let's move on to the cleaning. This step is totally optional. I want to do it, but I know there's a lot of people that don't like using chemical cleaners, or this just may not be necessary for you. I'll just be doing the quick clean version of this process, so this entire bottle is going to go into the expansion tank with distilled water. I'll get the car running, get it up to operating temperature, and then keep it running for another 10 minutes. During that time, I'll also have the heater on high and get the fan going on high as well. When that's done, I'll turn off the car, let it cool, drain this out, and then I'll do the same process but only distilled water, exactly like the rinses we've been doing this whole time. No matter what product you choose to use, the goal here is just to break loose any major buildups of mineralization and metal oxides that exist in the system as a result of not changing coolant for a while and metal components existing within the system. If you're wondering why I'm doing this step now, it's because I want to get as much out of the system before I replace the parts, even if some of the parts I'm about to replace have some of the buildup in them. One of the things I'm not touching is the heater core, which I think could be a big contributor, and the whole system has lots of nooks and crannies and places for mineralization to build up. The cleaning is done, and I just took a sample from the drain pan. I'm happy to see that the cleaning sample here is a little cloudier and a little darker than the last few rinses that went through. Here's a quick peek at the drain pan as well. I hope you can see this, but there are little flecks of metal flake and little white chunks of stuff scattered throughout the coolant. As soon as the cleaning was complete, I moved on to the follow-up rinse, and this is actually the first sample that's come out that is a little pink, but actually quite clear. It is still a little bit cloudy because we know that every time we do a drain, we're not getting everything out of the system, so there's some remaining bits of coolant in there from the cleaning cycle. But all in all, I'm pretty happy, and it does prove that the cleaner did get something loose. Now that we're done with our little cleaning experiment, it's time to move on to the thermostat. For replacing the thermostat, as usual, I try to get my information for how to do it in a few different ways. One is always stopping in on the Bentley publishing manual to see how they would do it. In my experience, there's some good advice in here, but they tend to oversimplify and don't mention things that would actually just make your life a lot easier. So they want you to disconnect the battery, and by the way, if you haven't done that already, do that now. Make sure you pull off the negative battery cable because you could short circuit one of the circuits or accidentally electrocute yourself. Just make sure that it's disconnected anytime that you don't need the car to be running. Anyways, they would have you take off a sensor, pull up an evap canister, and then remove the accessory belt and the belt tensioner, and I am going to do that just because my car has never replaced the accessory belt or the related components, so I'll be taking that extra step. Then take off the alternator, and then remove and hang the AC compressor. Then they just make it sound like you can take off the hose that's connected to the thermostat, and then take off this accessory bracket that's near the AC compressor, and then 3 more bolts and the thermostat's out. First up, we'll take our 17mm wrench and use it on the accessory belt tensioner and move it clockwise to loosen it up and take off the accessory belt. Again, this is optional, but since I'm replacing the belt tensioner, you can take out 3 13mm bolts, and those will get torqued down again later at 17 foot-pounds. The next step is technically non-essential, but I think you'll find it helpful to get more access to the alternator and then the parts coming up after. You can remove the upper radiator hose just by taking off the band clamp where it connects to the hard water pipe, so you can move this hose out of the way when you're working. And to remove the band clamp and all the rest of the ones that'll be coming up throughout this video, I'll be using my Schwabin locking hose plier set. Super handy. If you want to see more about that, I did a tool review on it. You can check it out up here. Now we have a little more working room here. Another optional but useful step is taking out the silicone pipe that connects the driver's side intercooler up into the intake manifold. Now it's time to start removing the alternator, and we'll begin with removing these 4 6mm hex or Allen bolts right here, and note that when we're torquing them back into the engine later, they go in at 17 foot-pounds. Now with the 4 bolts removed, you'll see that the alternator is still sitting in place kind of gingerly, which is great, and it's not falling out. And you can move on to taking off that black cap with a flat-edge screwdriver off of this 13mm nut right here. Doing that will release the alternator from the terminal cable that it's attached to, and note that when it comes time to put that nut back on, it goes on at 12 foot-pounds. The only other thing you need to do is remove this sensor clip right here, and I'll be doing that with my pick set. Our effort now is going to go into just clearing out the minimal things necessary to get the thermostat assembly out, which is this black plastic piece right here. Next up, we can gain more access and get movement on this hard pipe by removing this T30 torque screw right here, and the second one on the top right here. Now with this hard line loose and pulled out of the way, and this temporary zip tie undone to release some of the cabling, you'll have enough access to take out this metal clip which will pull off, and then you can remove the lower radiator hose off the bottom of the thermostat. Now that the hose is off, I can show you something else kind of helpful. You see the 2 notches at 12 and 6 o'clock? Those correspond to 2 tabs that are on the bottom of the thermostat that I just pulled this off of. And actually the 2 large hoses of this size that connect to the top and the bottom of the radiator also have these notches. And I find that it's easier to wiggle these hoses off when you're pulling on the hose and kind of wiggling it in the same direction as the notches. I was also interested to see that there's about 1.5 inches of some white sort of filmy stuff on the inside of this tube, and there's some more on the end of the thermostat, not surprisingly. I am curious to know when this assembly comes off, if this had anything to do with my problem, or if I find more as I go here. So now it's time to move on to the upper hose. We have to do that because the middle one also has to come out, but it's tucked behind the top one, so if this isn't loose, that one can't come out either. To remove the top hose, you have to do at least one of 2 things. One is remove the band clamp right there where it connects the hose to the thermostat. You can just slide that down. You might find it's easy to use a pick to slip under the rubber there and pull it off. But if you want a little bit of extra slack in the line, you can take out an M5 triple square, which is tucked right behind the wiring loom, right here. Now that the top hose is loose, we can focus on the final hardline connection that's in the center. Now this pipe is held solid by a set of brackets that are a little bit over here above the oil cooler. And to remove these, you want to take out two 6mm hex bolts that are held in place right there. And when you put those back in later, those go in at 11 foot-pounds. You should also be aware that there's an additional O-ring that sits on the hard coolant pipe that goes into the middle pipe of the thermostat. It's not a bad idea to check that out and replace it if necessary. We're on the home stretch now, and all that's left is taking out two 5mm hex bolts, and those will go back in later at 11 foot-pounds. And now we'll look at the block. So I'm happy to see that the water in there is quite clear, meaning my coolant flushing went pretty well. But obviously there's a little bit of oxidation around where the thermostat mounts up to the block, and I'll clean that up and protect it before I install the new thermostat. Alright, so the thermostat's out, and it's sitting next to the new one for comparison, but let's take a good look at the old one to see what the condition was. If you look at the middle and top pipe, it's almost completely filled with that white mineralization that we saw earlier. And the back has tons of it as well. Looking in on the thermostat itself, look at all the blue and green oxidization that's built up on the mechanism. And we have lots of rust oxidation on the back of it. It was even starting to crack the seal where it was sealed to the block, so I'm glad we're changing this. If you also look on the left hand side here, the pipe that's in my hand, look at the black goo that was probably the old seal inside of this piece that's just been seeping out through the sides. I'm going to crack this open in a second to get the thermostat out and do a boiling water test to see what temperature this thermostat's actually opening and closing. To test the thermostat, I'm going to submerge it in water to simulate the coolant mixture inside the thermostat housing, and then I'm slowly going to turn up the temperature to see when the thermostat opens. The Bentley manual says the thermostat should start to open at 85 degrees Celsius and then open a full 7mm by 105 degrees Celsius. If you're wondering why the coolant mixture wouldn't be boiling inside of the car at a temperature above 100 degrees, part of the credit goes back to the expansion tank cap and its ability to pressurize the whole system. It's that pressure that raises the boiling point of liquid and makes a temperature like 105 degrees not dangerous. So I just moved past the 80-degree mark, and just as I was repositioning the camera, it actually already started to open. So I think it was opening early, actually, but we'll continue watching this all the way up to the top of this thermostat, past 100 degrees, and see when it starts closing again, too, on the way back down. At just over 85 degrees, you can see the top of the thermostat is very open. It's about 92 or 93 and the water is boiling more than we can see the thermostat, so I'm going to stop it here, pull it out, and we'll see if we can measure the opening distance. Just took the thermostat out at about 95 degrees, and what I'm seeing here is at least 7mm. This thing obviously just popped. It's closing because of the decrease in temperature, but it was at a full 7. There's no doubt about that. Look how fast it closes. With the stove off, I'm just letting it cool down now, and we'll try to verify at what temperature the thermostat fully closes again, because I suspect from on the way up that it's opening early. We're at 86 degrees and I can see it starting to close slowly. We're coming down close to 80 degrees now, and you can still see that the thermostat is quite open. So from what I saw there, the thermostat was opening almost 5 degrees too early, and then of course staying open too long as it cooled back down. And ultimately, that would probably produce a colder coolant mixture, which actually doesn't sound like a bad thing, but it's enough to throw out the ECM and probably throw a fault code. Now for the really fun part, we'll be looking at the rear coolant flange and the coolant temperature sensor. This is a job that isn't covered by the Haynes or Bentley manual, and something you can freestyle depending on how much stuff you want to take off and how many extra parts you want to replace. Before we start the work, let's just take a look at the piece because it's going to be difficult to see when it's actually on the engine, so being familiar now is helpful. There's 3 prongs. One on the right is for the temperature sensor, that right there, and is held in place with a clip just like that. The one on the bottom is going out to the heater core, and as you can tell by the notch on here, just like we saw on the hoses that connect to the radiator and to the thermostat, that hose is going to take a little wiggle to get off, and that one's held in place by one of those familiar metal clips. And then on the left, that one goes out to the thermostat and is held on by a hose that has a band clamp on it. The flange is sitting under the timing chain cover, which is this silver part right here, probably about 6 inches below that. I fully recognize that some people have completed this by sort of laying on top of the engine and wrapping their arms around the sides, only removing a few hoses around each end to get access to do the job, but I'm opting to go the slower, longer way by removing a few things out of my way to make the job a little bit easier. Starting on the right hand side just in general, to create some arm room, I'll take off this breather hose, which is just the 2 band clamps, and then the expansion tank. So I already have the top hose off, and I'm going to slip off this band clamp right there and take off the bottom hose. There is a sensor on the bottom, so make sure you unclip that before you just try to pull the whole thing out. Otherwise, it's just that one Phillips in the front, and then you'll tilt the front end up and then slide it up and out. Before I start getting into any vacuum lines near the vacuum pump, I want to get some wiring out of the way. So the goal here is to remove anything connected to this wiring harness right here. So that is 1 and 2 sensors on the high pressure fuel pump, one more sensor right there on the top of the N205 valve, and then 1, 2, 3, 4 on these coil packs, and along the way you'll have to take out these 2 T20 Torx screws. To finish up in this area now, and to get a little bit more flexibility in the harness, we need to remove this single M5 triple square that holds this little black bracket down, followed up by 2 T20 Torx screws that hold down the N205, in which case you can pull this up and out after you're done. But when you come back to these 3 screws, you're going to want to put in the triple square at 7 foot-pounds and the 2 little T20s at 4 Newton meters. Back on the right hand side, there's a black metal line that runs along the firewall that would be good to get out of the way. It connects to the back of this rubber hose on the N80 valve, and that's where I'm going to disconnect it right here, just for convenience sake. And it's held in place by 3 plastic retaining clips. There's one right here, one down there, and then a third right there. And once this is loose, we can just slide it out and kind of tuck it away on the left hand side. Now that we've got some of these lines gently tucked to the side, and I'm holding them in place with a reusable zip tie, I want to prepare to remove the vacuum pump. For now, what I'm going to do is remove this crimped band, and I'll be replacing this with a little bit more user-friendly style clamp when I'm done. And if you need to get a little bit more leverage on it, you can just pull this vacuum line out of the firewall, out of this grommet, just by pulling it straight out towards you. We're very close now to the point where we can remove the vacuum pump from the back of the cylinder head, and it's held there by 3 bolts. The top 2 bolts are quite accessible, but the bottom one also holds on a bracket. This bracket holds the wiring harness right here into place, and it also has a ground wire connected to it as well. So to remove that bracket, we need to remove 1 T30 Torx screw, and I'm going to try to give you a frame of reference for where it is without shoving the camera into the back of the car here. So all you need to know is that the bracket for it can be seen right there through the crack. So your frame of reference is about here, and it's straight down. It's actually very easy to feel and find. I'll put my finger on it. You can see through the hole there that I'm touching it. It's just right there. You can reach in with your right hand and then reach around with your left with the ratchet and just guide it into place. It's actually pretty easy. Speaking of which, you might want to buy one of these mini ratcheting bit drivers for just this job. They're usually pretty cheap. The idea is that it is a ratchet that can fit into tight spaces, and all you need to do is slip an individual bit into the head for it to work. The last 2 T30s are very easily spotted. There's just one right here, and the other one is right here. Alright, the vacuum pump should be out now. So the torque specs to put all 3 bolts back in is only 9 Newton meters or 80 inch-pounds. But the top 2 took quite a bit of elbow grease to come out. I have a feeling they had Loctite on them, which makes sense of why it was so difficult to break them free, and I recommend putting some Loctite back on all of these on the way back in too. So I was pretty happy with the condition of the vacuum pump when I took it out. I wasn't concerned in the first place because I didn't see any oil leaking from where this connected to the back of the cylinder head, but it still looks pretty nice. Although, I started reading a little bit more, and I realized that any pump ending with E is part of the ones that are essentially the oldest and least functional of all of them. Audi recognized that there was an oil leak issue from both the inside and between where this plate mounts onto the back. So they released a few more revisions that would be F, G, and H, and that fixed it. What they did was increase the O-ring size from 53 to 56 millimeters, and they changed the positioning of it as well, and that seemed to do the trick. So no matter what, if you have a vacuum pump that you're taking off as part of this coolant flange process, plan to at least change the O-ring just out of good habit. But if you have an older one like this, you may want to consider changing the unit entirely. That's what I'm going to do, even though that's going to hurt the pocket a little bit. There's about $300 as part of this price, at least in Canadian dollars. But I wouldn't be able to sleep well at night if I knew that there was a much better revision out there and I potentially had an oil leak on my future hands. Next, we'll be removing the coolant temperature sensor. That's the gray part sticking out of the left here. It's held in place by a black clip. It's got little grips on it and a hole on the side if you want to get a pick in there and pop it out. Since the coolant flange is oriented kind of like so on the back of the engine, you'll be pulling the clip towards the cabin to get it out and release the sensor. Here's a better view from the back of the engine, so you can easily see that the clip is pointing towards the cabin and will just be pulled out. And then of course that will release the temperature sensor from inside of the coolant flange housing. And you'll have to pop the clip off the back of that to replace the sensor entirely later. I'm coming to you from the future of this video because I'm further on in this process, but I have a piece of hindsight advice I want to share with you right now, is that all the hoses that are in tough to reach spaces in the back here, especially the one connecting the coolant flange to the hard pipe, before you take it off completely, take a little paint marker and just make a line somewhere on the hose wherever it connects to the item that it connects to. Later on in the video, I'm going to tell you to pre-assemble as many of these parts before you reinstall them, and that is true. But even when you do that, unless you have a perfect alignment of the hoses, it can be a little tricky to make final adjustments when it's already tucked behind the car. So the more exact you can be at that point, the better. Okay, that's one line down. Now we're going to move on to the one that splits out into the hard coolant line and then the thermostat. So what we want to do is take off a band clamp. We want to take off this one right here, not the one down where it connects to the flange itself, because we want to just create a little bit of flexibility in this line to separate these. And when we take out the flange, it'll just come out with this hose attached to it. In order to create the flexibility and room to pull the hose out though, what we want to do is free up the hard coolant line. What we'll do is remove two T30 Torx screws. There's one here, and another one right here, and one M5 triple square. Okay, last one. But what we're going to do for the moment is just prep to take it off just by removing the metal clip. So what we want to do is take off that metal clip right there. This is a good time to do it because there's some rigidity in the flange, so just pop that out, and then the next step is actually going to be taking out the coolant flange itself. Once we do that, we'll have way more flexibility and leverage to just pull up and let that hose drop off the bottom instead of attempting to push down on the hose to get it off the flange. Okay, we're on the home stretch now. All we want to do is take out the two T30 Torx screws that go into the flange. At this point, there's so much removed back there that I guarantee if you just slip your hands around the top, you'll feel the first. And then if you put your hand around the back through the V here, and then reach through, you'll feel the bottom right one as well. And hopefully, you're done. So these two screws came out quite easily for me. They were barely torqued in there. By the way, I couldn't find the torque specs for these two bolts, so if anyone knows what they are, please do post them into the video. You know, I gotta say that this project wasn't that easy. It was every bit a pain in the ass as the internet says it is, but I have to say I'm super validated for wanting to do this and completing it. Once I look inside the flange here, it is just absolutely coated with this white stuff, but the biggest surprise was when I pulled this out, I thought, where'd the seal go? In fact, where's the rest of the housing? Why is the edge all jagged? When I took my mirror and flashlight and went back to the back of the block, I saw some black things sitting inside the housing, and I took my pick out, and lo and behold, the seal was sitting in there. It's super swollen. But when I came back to my bench again and saw the broken end, I thought, well, where's the rest of the plastic? And went back one more time and pulled yet another piece out. So mine had completely cracked. I can't even believe there wasn't any coolant leaking. If we take a look at the temperature sensor too, it's got a real nice patina on it, just like the thermostat did. So obviously these were of the same vintage and were corroded with the same material over time. The state of the union so far is that, other than the parts I planned on replacing anyways, I've now inspected all the lines and hoses a part of this cooling system that we've touched so far for any of that white stuff. If there is white stuff, I'm either going to replace it or clean it, and that's depending on price and effort. So the plan is to replace the hose that connects the coolant flange to the hard water pipe and the one that comes off the V of the hard water pipe going back down to the thermostat. I'm going to clean the hard water pipe, I'm going to clean the upper radiator hose, and I'm going to clean the bottom radiator hose. Now on to the last, more involved part of this process, the water pump. Okay, so you already know that we're in Audi Service Position, and we're actually in a modified version of it, Audi Service Position Plus, let's say, where a few extra connectors are disconnected and the hood latch cable is loose, and essentially we have a little extra room for the lock carrier to be pushed forward. But I'm going to coin a term called Audi Service Position Plus Plus. That just means we're going to remove the very few remaining items that are holding the lock carrier in place so that it can free float off onto the front of the lock carrier pins, but we're going to do a little trick with the AC condenser and lines to allow us to do that. I'll add that moving into Plus Plus is going to be a lot easier if you have a system of lock carrier pins like I do. That being said, you can use anything to support the lock carrier. You will need to support it somehow, or if you're feeling really adventurous, you can actually remove the lock carrier entirely. Lastly, I do have my power steering cooling line removed. You can guess where that was. And if you need flexibility in that, you can just loosen up this torque screw right here, and that'll give you the flexibility. On both sides of the vehicle, remove the two 6mm hex bolts that attach these sensors with the yellow clips on them. And then just on the passenger side, you can release the top of the intercooler hose from the intercooler. And on the driver's side, you can detach either side. Mine's already out, but the intercooler hose is down at the bottom. I wasn't able to find the torque specs of these two 6mm bolts, so if you know what they are, please do share them in the comments field. Right now I'm just using the Guten-Tight principle, which is just putting the bolts in firm to the touch. Also pop out the sensor right here that connects into the condenser line. We can remove the 4 T30 torque screws that hold the AC condenser onto the rad support. When you go to put these 4 screws back in, they get torqued down to 6 Newton meters. Also, when you put the power steering cooling line back on, that is 9 Newton meters. And here's the intended result. So make sure you have something to support the weight of the AC condenser while it's hanging on the lines, because that's exactly what you want to do. You do not want to break open the AC unit and release any of the Freon into the atmosphere. This will allow us to move the lock carrier even further out now that nothing is standing in the way. All that's left now is removing the final 2 T30 torque screws that are holding the lock carrier into Audi Service Position Plus, and you can pull it on forward into Plus Plus. And there we have it. AC condenser is supported, front lock carrier is hung and supported as well, and look at all the room we have to work in the front. Since my accessory belt tensioner has already been removed, next up we want to remove this band clamp here to get some flexibility in this hose, because after that we need to remove the top of the timing cover. Now we can remove the 2 T30 torque screws that are holding the top of the timing cover on. There are more T30s coming up later with the bottom part, and know that when you put these back in, they get torqued to 7 foot-pounds. Time for an important and fun part. What we want to do is find top dead center for cylinder 1. We're going to be doing that by lining up 2 timing marks. One of the 2 are on the camshaft sprocket, which is this thing right here. You're likely to see a timing mark that already exists on the outside of the gear somewhere. Mine's obviously right there. And the point we're trying to line it up to is this arrow right here. You'll find another timing mark, usually as a struck line into the back edge of the crankshaft pulley. To put cylinder 1 into time, all we'll do is take a 12-point or spline socket, and this is 19mm. It's also 3/4 inch. And we'll be turning clockwise on the center bolt inside of the crankshaft pulley. Now we can go ahead and remove the 6 M10 triple squares from inside. All we'll do is add some counteracting force with our spline socket in the middle and remove these 6 bolts. Those bolts will go back in later at 17 foot-pounds. Now with the 6 bolts out, you should be able to pull on the pulley towards the front of the car to get it off of where it mounts onto the crankshaft gear. If it sticks, that might not be a surprise because this area is prone to rusting, so just give the outside a gentle tap with a hammer all the way around. Now to remove the lower timing cover, we need to remove 1, 2, 3, 4, 5. 6, 7 T30 Torx bolts. Now that the crankshaft pulley and lower timing cover is removed, notice how we've lost all signs of where timing is on the crankshaft gear. For some added confidence, all I've done here is taken my automotive paint pen and I've made a line on the top of one of the teeth on the gear and then cleaned off a section of the block to make a corresponding mark right beside it so I always know where time is. Now we're going to loosen up the tension roller by removing this 13mm nut. When that nut goes back on later, it'll get torqued down to 18 foot-pounds, but with this roller loose, we'll be able to remove the belt. If you're doing this job to look at some other component and you do plan on reusing your timing belt, make sure you note what direction of travel it's been running in because you should not reinstall it in any fashion. It has to be moving the same way as it did before. Now with the belt off and the fact that you're probably replacing many of the rollers in this system, you can just go ahead and pull the tensioner roller off the front. Now we can remove both the upper and lower damper rollers. This top bolt is a 13mm bolt and it can be torqued down to 18 foot-pounds later. The bottom one is a 12mm bolt and that'll get torqued down to 26 foot-pounds. Note that there are some slight differences. The bottom roller has a deeper lip on it and they are color-coded. Typically the top one will be red, the bottom one is often blue or black. Now finally, the moment I've been waiting for, we can remove the water pump by removing these 3 10mm bolts and those will get torqued down later at 11 foot-pounds. I just did a little bit of cleaning. I took an SOS pad, you might call it a Brillo pad, but either way it's one of those kitchen scrubbers that are made out of stainless steel wool and that blue detergent. I dipped that in a little bit of water and I plugged up certain holes to make sure the foam didn't go anywhere, but I just gave the outside a little scrub to clean up that mounting surface on the outside where the water pump would mount to. There's also a little bit of rust remaining inside the cylinder where the water pump impeller is going to be spinning. That might be there just because of incorrect coolant mixture or different contaminants being inside the system before, but I'm going to do another cleaning cycle once all these parts are back on, and I'm confident over time with the correct coolant mixture that this will clear up. So here is the new pump next to the old one. They look identical on this side, but when we flip them over, the obvious and important difference is the impeller construction. So this OEM one right here is a plastic impeller. It's said that through the heating and cooling cycles over time, these can crack and then turn into little pieces, and of course the mayhem ensues after that. So an upgrade you can do is one like this. So on this mile heavy duty one, it is a cast impeller. Now that the water pump's going back in, make sure you moisten the O-ring going all the way around with coolant before you install it. And here's a look at the new lower and upper damper rollers. Some people call those idler pulleys. It's the same thing. You can use those words interchangeably in this case. I did want to point out who the original equipment manufacturers were for the OEM pieces. So if you go to the dealer and buy the parts from them or go online, if you actually buy NTN, that is who makes these original parts. If I can get the lighting just right, you'll be able to see those words on the 12 o'clock right there inside. That's the lower. And on the upper, it's INA. And you can see that at 12 o'clock as well. So if you buy those brands, it's as good as the dealer. Till now, I didn't know that those were the original equipment manufacturers. And by chance, I bought NTN for my lower pulley. But I went with Euro for the upper just based on price. I thought they were all the same. And although I'm still sure this will do the trick, I did notice that when I unpacked it, you can see on the right-hand side there, 3 o'clock, there's a little bit of pressing on the seal that happened when they put the spinning piece in the middle in there. Doesn't look amazing. I'm sure it'll be fine. It spins well when I tested it. It's got some good movement on it. But I just thought I would note that if you're going to buy aftermarket as well, go with the INA. Both rollers are now installed with the specs that I mentioned earlier. Make sure they spin freely. And I did notice on the bottom one that there's a little bit of deflection, some wobble in the lower idler roller. I think that's okay. I put on the old one again just to double check and it had the same type of feature. If there was a lot of movement, I'd be concerned, but I feel that this is okay. Next up, we have the tensioning rollers. Here is the Euro aftermarket one that I bought, and I realized that the original equipment manufacturer is once again NTN. You can see there at about 3 o'clock. I think the quality of construction is pretty good. The only thing that I noticed is that there's a little bit of play on this inner cylinder, more than the OEM one. It has a little bit of up and down wiggle and movement. Of course, it's supposed to spin, but it has a little bit more movement in it than the OEM one. For now, all we want to do is mount the tensioner, make sure that the bracket on the back here has a chance to slide into this nice little circle that it hangs in and rotates in, fully seated. You can give it a test just by moving this around, and then take your fresh washer and nut and put it on here just hand tight. The Bentley manual asks that you put the timing belt over each component in a specific order. They want you to slip it first between the upper roller and the tensioner that we just put in. Then take the slack and loop it over the camshaft gear. Then make sure that the water pump is covered on the bottom. And then with the remaining slack, make sure it's pinned between the upper roller and the tensioner, of course, also inside the lower roller. I'd say the more obvious and important advice at this point is when you're adding the timing belt back on, just make sure that you're not rotating the crank or camshaft gear and keep those timing marks where they are. Now it's time we take out all the remaining slack in the timing belt by tightening up the tensioner. Before I do this on the car, I wanted to show you this on the manual because what we're trying to do is line up a metal square tab with a notch in the tensioner. Okay, now on the car, we're going to be turning this clockwise so that this metal square right here lines up with this metal notch right here. And I'll do this by turning my wrench with the 8mm hex bolt in it to add tension. At the same time, I'll be holding the breaker bar to make sure that the crankshaft gear doesn't move at all. And when everything's lined up just how I like it, I'm going to put the torque down on this nut. And here's the result of a properly tensioned tensioner. This is a great chance for a quality control check. Now that the tensioner is set as you like it, make sure your camshaft timing mark is still where it needs to be. And down on the crankshaft gear as well. That should be good. Quality control test number 2 is 2 full rotations with the breaker bar and socket on the crankshaft gear. That'll give you 1 full rotation on the camshaft gear, and the result should be the timing marks perfectly lined up again. It's natural to feel some resistance as you move through the compression stroke, but if you ever hear metal on metal or you really feel stuck, then something's definitely wrong with the timing and you need to stop, back off, and revisit the timing adjustment marks. A final check before bolting anything down is you can pop on the lower timing cover and the harmonic balancer, and if the timing mark on the outside of here still lines up, then you're still in good shape. Go ahead and torque down the 7 T30s that hold the lower timing cover on and the 6 M10 triple squares that hold the harmonic balancer or the crankshaft pulley onto the crankshaft gear. Time to put the upper timing cover on and torque down the 2 T30s on each corner. There's a groove in the bottom of this, and it just needs to sit into the corresponding groove on the top of the lower timing cover. Last, we'll reconnect the turbo coolant hose onto its feed pipe.
While you have the lock carrier forward, this is a great time to test or replace the N75 valve. Unlike the diverter valve, which is actually pretty easy to get to from underneath the car, that's not exactly the case with the N75. I'm going to do both the test and replacement in a different side video that you can follow along here.
Before I tip the lock carrier back forward again and lose my space, I'm also going to be replacing the idler pulley or the guide pulley as a part of my refresh for the accessory belt system. Right now there's an M12 triple square in there, but when I replace it with a new piece, I'm going to be putting it in at 23 Newton meters or 17 foot-pounds. I'm done up front for now. I'm just going to bolt up the AC condenser and reconnect a few of the other sensors and clips that allowed me to get into Service Position++. So at that point, we can go on to the Coolant Temperature Sensor and reinstalling the Coolant Flange. I mentioned earlier that instead of replacing these expensive parts just because they're a little dirty on the inside, I wanted to find out a way to clean the inside of the hard water line and the top and bottom radiator hoses. And what I ended up doing was using warm water and white vinegar. All I did was cap off all the openings with saran wrap and held them tight with elastic bands, and I just sort of sloshed around that solution on the inside for a while. I think it came out pretty nice. There's still some white film down in the hoses that I can't seem to get off, not with this mixture at least, but all the white film that was built up on the inside of the black plastic came off entirely. I feel like that's the important part too, because those are the areas that actually seal to the radiator or the thermostat housing, so I'm pretty happy with the result. If you also consider the fact I've already run a leading brand of radiator cleaner through this entire system, and I was still left with that much film on the inside, I'm actually kind of wondering if vinegar is the way to go in general. So for those of you out there that don't want to run a chemical-based cleaner through the system, maybe vinegar is actually just the way to go. I just noticed something kind of cool. So it can be a pain sometimes to get these metal retaining clips down onto their fittings if there's something blocking each side, because usually you're working with a pick to sort of shimmy it around and then down in its final position instead of just shoving it straight down. But what I noticed is that there are these step grooves on the side right before the final position of where they get pushed down. So you can actually pre-mount the retaining clips like this, put the hose on, and then just push down on the top and they'll fall straight into place. It's time to reinstall the coolant flange. The trick here is to pre-assemble as many parts as possible to reduce the headache of trying to fit hoses, clamps, clips, and seals while you're working behind the engine. I get to cheat a lot here because my hard water line is out and I'm replacing both of these hoses, but at the very least you should pre-assemble the seal on your coolant flange, the seal on the temperature sensor and the sensor itself, its clip, this black clip that'll go to the heater core supply line, and this hose with its 2 clamps. As a small added bonus for me, I don't want to go back with my locking hose clamp plier set all the time, so I'm replacing all of those styles of band clamps with the screw top style ones. Let's spend a second on the coolant temperature sensor. It's got a few different names. For short, usually it's the CTS, but in books like this, the Haynes Manual, you might run into the phrase ECT sensor. It's the same thing, they just call it the engine coolant temperature sensor. But the last term you might run into is the G62 sensor or green sensor. That term is in deference to the coding system for VAG cars, that's Volkswagen Audi Group cars, and that code is also equivalent to the P116. There's a few there, 116 to 118, related to the engine coolant temperature. It could also be a wiring problem as well, but often it is this sensor. I feel as though there's some misleading information out there when it comes to the G62 green sensor. You might find that one as an upgraded sensor for this same OEM piece, but it's a 4-pin, whereas this one is a 2-pin. It says that that sensor can be used on a number of cars from the B5, 6, A6, a lot of the B7 S4s, and even the 2-liter like mine for the A4. But I actually don't think that last part is true. If we look at the harness for a second, you'll notice that it only has terminals to accept a 2-pin and not a 4. Nonetheless, the job of this sensor is to sit inside the coolant flange and relay coolant temperature information, obviously, to the ECU. Here's the receiving end on the harness, and you can tell that it would never accept anything other than 2 pins. When reinstalling the CTS into the coolant flange housing, I recommend putting in the seal first, seating it all the way at the bottom, because you might be surprised how far in it needs to go. Then put in the sensor behind it, and then as a test fit to make sure it's in all the way, put the black clip in, and make sure that the clip edges sit behind the metal on the CTS, not on top of it. On the inside, you should be able to see a little bit of the temperature sensor sitting inside the housing. Here it is, fully assembled. All the band clamps are loose because I know that the final adjustments will have to be made as everything gets installed. But I've also put coolant as sort of a sealant and lubricant on all the new rubber pieces, whether it's on the inside of the hoses or on all O-rings. One word of caution when you're reconnecting the heater core supply line back onto the bottom port of the coolant flange. So once again, we have a fitting where it has the little notches on 2 sides that have to fit around a notch on the receiving side. What you're going to try to do is push this on, and you'll realize that a bit of the notch on the coolant flange is still showing. It's not flush with the top of the supply line. That's going to make you feel weird because most other cases, they are flush. But if you look at the total depth of the notch in the hose, it's actually shorter than the total length of the notch on the flange. So it's okay if it doesn't look like it's up all the way, it is. So the flange is back in. Took a lot less effort than it was to get it out. We've got the heater core line put back on. The hose is nicely adjusted. New style band clamps are on and tightened down everywhere. And now we just want to reconnect the hard pipe with the 3 screws that we took out in the first place, and then we'll reconnect the end to the top of the radiator hose. Time for the vacuum pump to go back on. I did decide to upgrade to revision H, and fundamentally they do look quite similar. The biggest difference seems to be how it's driven off the back. This style is a lot different with a ball bearing in the middle that it rotates around, but you can see now that the seal sizes are definitely a little bit different. This one's larger. And if we look at the backing plate, this one is thinner, and the profile on the back is very flat, although I don't think that it has much to do with anything compared to this one, but you can see that it's probably about 50% thinner than the old revision. On the way in, I'll be putting medium strength thread lock on all 3 bolts, and then I'll lube up the O-ring with some motor oil. Remember that this bottom one also holds on the wiring harness bracket, so I'm going to start with the top 2 and then finish with this one. Keep in mind the back of the cam drives the vacuum pump, and obviously since the cam is not going to rotate right now, while you're installing the vacuum pump, you may need to rotate the tab on the top. The vacuum pump's now installed, but only with the top 2 bolts. We have the final long third one that's going to go into the bottom and hand still. Before we get to install that, we want to do 2 things. One is to reconnect the coolant temperature sensor clip, which is right here, and that's going to go back into the bottom of the temperature sensor right there. And then what we're doing is preparing to reinstall that metal bracket right there. There's the hole right in the middle. We need to pull it back up and install it into the bottom hole right there that's remaining in the vacuum pump. The vacuum pump is 100% in place, and attaching the bracket along with that bottom bolt has made this harness back here kind of stand a little bit more upright and come off the back of the firewall, which is great because now we're just working in perfect reverse order. We're going to take this vacuum line and tuck it back under this fuel line right here and reattach it to the 3 clips along the firewall to put it back into place. And then of course we'll reconnect the end here into the back of the N80. Great, now we can move on to reinstalling the N205 valve. That of course goes in right here with its 2 T20 screws, and this is an excellent time to replace the part entirely because it is a good maintenance item to change out. I'm not going to today. I'm going to replace it with a part I already have in a dedicated video for you guys, but in the meantime I've cleaned this up and I've relubed the seal, and I used my power probe tool to make sure that the solenoid is functioning as it should, and it is. So you can reinstall that, and then next you'll just want to move on to this M5 triple square that we loosened up earlier, because that holds on this black bracket, so you can lift up this harness and put the M5 right through that little hole right there. Good job. Things should feel pretty natural now coming back into place. You're doing good. What we want to do now is reconnect a bunch of the clips and sensors that we took off earlier. So we'll put on the coil pack harness and the 2 T20s that hold it into place. And just pay attention. There's a bunch of clips that you probably undid and you want to reconnect to make sure that there's nice clean install going back in. Example being here, reconnect these guys. The black bracket that we put in near the N205's got a hole in it because the zip tie bundle has a little plug it needs to go into. Reconnect the N205. Here's another connector that goes into the top of the vacuum pump right there. High pressure. And then this line right here for a nice little install. It actually wraps around the PVC, goes in here before reconnecting. There's only 2 things left before we're back to reinstalling the thermostat. We want to reattach this final vacuum line that we took off of the vacuum pump earlier. Just make sure that it's tightened back down into its plastic clasp at the bottom here, and then put the connection back into the firewall, and of course plug this end back into your vacuum pump. Once that's done, we want to reattach the top breather hose that connects the manifold to the PCV. Now the thermostat. Since I removed my lower radiator hose and I want to make my life as easy as possible, again I'm going to pre-assemble some of these parts. So I'll slide this on and hold it in place with the retaining clip. We already know that these have the notches on here, but check out your new part. I actually had a bunch of plastic from the mold that was still attached, and right up next to where these notches would be sliding in, I cut those off to make sure that the fit is really good. And I have a fresh seal for the metal line that goes into the middle hole here, some fresh hardware, and I'll be lubing up any of the rubber with a little bit of coolant as well. Hopefully it was easy for you to slip in the thermostat assembly and tighten it down. Of course, I've also got my lower radiator hose on. Now, while we have the hardware out over here and some good flexibility in the lines, we're going to reattach the 2 lines. So we have the metal middle hard line right there, and I've got my fresh seal on it. You just have to push it into place, and then we'll reconnect our top hose as well and put on the band clamp. Great. Now you probably have this last hard line here pulled out of the way, but it's time to reattach it. So lift it back into place, and there's 2 T30s that you need to reattach to hold it there. We have the silver one that's going to be on top, and then you have this black one with a bit of a ring around it to hold it in place because it passes through both of these black brackets right here. When you're happy with those 2 hoses, all we have left are the 2 6mm hex bolts and the 1 M5 triple square. And of course that goes back down right above the oil cooler into the brackets that we took them out of earlier. Now that the hardware is in and all the lines running into the thermostat are nice and tight, all I did was reinstall the ground wire for the back of the alternator and another wire that goes into the zip tie band back in place, and we're ready to drop the alternator back in. It's going in with those 4 long bolts and put some Loctite on there, And remember to reconnect the sensor at the back and of course attach the ground wire to the 13mm nut with the cap on it. And here's a quick peek at the new tensioner next to the old one. By the way, this is such a great time to replace these bolts. It's so easy and they're so cheap. Just go ahead and do it. So again, I purchased Vaco as the brand for aftermarket, and this time, both functionally and aesthetically, they are absolutely identical, and that makes me feel pretty good. What you're likely to see is a little pin, and this tensioner is already retracted, just like we were talking about the locking pin earlier. I think they just try to make your life easy, knowing that there's not a lot of space to work in, and you're wanting to replace the belt right after this. This pin helps you do that. Just make sure you pull the pin out later. Now we can put on the accessory belt, and of course there is a correct pattern for it. What you need to do is put it on the outside of the crankshaft damper, on the inside of the tensioner that we just put on, then up above the alternator pulley, then on the outside of the power steering pulley, back on the inside of the idler, and on the outside of the AC compressor pulley. There's only two things left to do to make sure that we can actually hold coolant in the system. We have to reattach the bottom radiator hose, and I've got my clip staged onto the side of it for that. Then of course we need the coolant reservoir. That'll go back into its two tabs, the one Phillips screw. Of course we've got to remember to reattach the sensor, and then we need to reattach the hose that goes to the lower rad, and then we need to reattach our overflow line to the top rad hose. So now that those items are in place, and before we fill up the coolant, we need to make sure the engine can breathe when it's started up. So I need to pop back in my remaining lower intercooler hose on the driver's side, but I've decided to give myself a bit of an upgrade. For the intake manifold hose, I have bought the ECS Tuning silicone 3-ply piece, and you can compare it to the OEM piece. On the side view here, you can see it's a 2-layer construction, whereas on the ECS one, you can see 3. And just looking at the profile, it's dramatically different. I don't think the performance is going to be too different, but I do like the fact that this has quite the kink right in the middle there, and this is a nice smooth flow. Done. And man, it feels good to see things back together again. So before I do the cooling system refill, I want to start with a vacuum leak test. I know that with all the parts that I just changed, it is possible that something isn't sitting quite right, and if I were to fill this up with liquid right now, something might leak. So before I do that and waste my money on coolant and have to pull things apart, I'm going to start with the vacuum leak test to see if I can actually hold pressure. To do this test, I'm going to be using this refill and air purge tool made by Schwaben that uses the Venturi effect. They call it their cooling system evacuation tool. This tool aids in the process of refilling your engine's cooling system after a servicing when it's empty, and to bleed out the air that is otherwise difficult to remove. The physics that creates the Venturi vacuum effect, which truly makes this tool useful, happens in the adapter. Air from your compressor will be traveling in through this valve and straight through the adapter. There's a restriction inside of the adapter that'll force the air coming in through a tight tube, which will actually speed up the air and subsequently creates a vacuum. This vacuum is what creates suction in the hoses perpendicular to the adapter and is ultimately what draws air out of your cooling system. Before I mount the gauge assembly into the expansion tank, I'm going to go into the car and turn the ignition just to auxiliary. That'll allow me to turn on the cabin fan again, so I'll put the heat on high and the fan speed low, and that should open up the heater core circuit and allow me to pull a vacuum on the entire system. This also means that the key needs to be in that position for this entire process. Everything's hooked up and ready for the vacuum test. I've got my gauge mounted and then the Venturi adapter connected. One end is being supplied air from my compressor at 90 psi, and then the discharge hose is running into a drain pan to catch whatever liquid comes out during the vacuum build. By the way, this gauge reads in inches of mercury vacuum. That's the INHG. On a typical passenger vehicle, the maximum negative pressure you can achieve is somewhere in the -15 to -27 range, so don't be concerned if you can't hit -30. That's probably not going to happen. Okay, the vacuum is stopped at about -23, and I'm going to wait for 2 minutes to see if that needle drops and see if I'm leaking. In the meantime, I'm going to listen very carefully around the areas we've been working in to see if there's a leak. It's been 2 minutes and the needle is still holding still at -23, and I couldn't hear any places where atmospheric air is being sucked into any of the spots that we've disconnected throughout this cooling system process. So I think I'm good. I'm going to release the vacuum for now and go prepare my coolant mixture. Coming back to the trusty Bentley manual, they have a chart in here for the cooling system capacity of all A4B7s based on your engine size. So mine being the 2 liter, I have a 7.6 liter capacity, which means if I did a 50-50 mix, I'd be mixing in roughly 3.8 liters of coolant. So for me, I know that my cooling system has almost 8 liters of capacity, and at a 50-50 mix, I'm almost using 4 liters of coolant. So at the very least, I'll be just a bit under minus 37 degrees Celsius, probably closer to minus 32 or something like that. But there's actually a little note on the side here that says cooling protection must be guaranteed to minus 25 degrees Celsius even when the Arctic climate is around minus 35. So I know I'm safe. Even with the premix calculations, it's a good idea to use an antifreeze tool like this when you're done to take a sample right out of the vehicle to make sure that you have the proper protection. You might end up adding more coolant or adding more distilled water after the fact. Before I do the mix, I want to take a second to talk about coolant, namely G11 versus G12 versus G13. G11 is the oldest and now considered to be outdated technology. Usually took on that green color, but I'll say that you can't rely on color alone when you're looking at coolant to determine what type you have, because some brands put dye in their coolant just as a matter of branding. As a general rule of thumb, if you have green coolant or think you have G11, just get rid of it, drain it, and replace it with something newer. There's very few coolants that G11 safely mixes with, and more than likely, if you try to top up your system with something new while G11 is still in it, there's going to be a harsh chemical reaction. G12 was the next evolution and usually took on more of a reddish color. It was a step in the right direction in terms of cooling performance and protection for the engine, and it was glycol based. Technically there was G12 Plus and G12 Plus Plus, but then G13 came out and succeeded both of them. This time it's glycerol based, and it takes on this purplish violet color. If you need to, G13 is safe to mix with G12. Not to leave it unsaid, you must mix your coolant with water, and it has to be distilled water. Without mixing any water in, you won't have the heat dissipation qualities that you need to have in your cooling mixture. In the same regard, never mix more than 60% of your total mixture as coolant. If you do, it's going to reduce the frost protection and engine cooling ability. How you do the mixing is obviously up to you, but for the purposes of my vacuum fill, I've decided to find a container that's actually larger than my total system capacity, and I'm going to fill it with even a little bit more than my system can possibly hold, so I can suck this all in one go, never having to stop and never risking introducing air. I know the exact process I'm going through right now isn't exactly commonplace though, so you might opt to put all the distilled water that you feel is necessary into your expansion tank first, and then follow it with all the coolant and just let the water pump do the mixing. I now have 8 liters of premix on hand. Here's my coolant jug, and I've redrawn the vacuum, so I'm ready to do the fill. I'm going to open the intermediary valve now to release any excess pressure in the system right here. Now we're down to 0. FYI, that container actually had 9 liters of 50-50 mix in it. I had a little bit of extra coolant left over after I did that original mix, and I decided to finish mixing it and add it to the jug. So after the refill process that we just did, I dumped everything left in the container back into these bottles, and I have a little bit over 3 liters here. So that means one of two things. Either there was a bit of coolant left in the system, and it took on as much as it could, which was around 6 during that refill, or the tool didn't exactly work, and now I have to watch the expansion tank on the startup of the car here and see if it goes down and it needs to be topped up. I just finished a quick inspection around all the areas once more. I used my mirror and my light to look in and check to see if there was any coolant dripping around any of the areas that we've been working on. I don't see anything. The ground is dry as well, so I think we're ready to go. It's time for the first startup. Since we started this project, I'll be very carefully watching the expansion tank while I run the heater on high as usual with the fan on low, but considering we did the timing and a few other things as well, there's lots to watch during this first startup. I smelled something a little weird and saw some smoke or steam coming around the back area, I think. So I shut it down. I'm going to decrease the level in the expansion tank and start up again. The second startup is complete now. I went all the way to operating temperature and then shut it down. And all the errors are gone on the dashboard, and no new ones are there too. Although there is a bit of a wobbling, or I might even say sloshing noise coming from the front. I don't think it's under the timing cover, sort of in here somewhere. I'm not sure if there's a problem yet. I let the engine run for quite a while, and it took a long time to get the top radiator hose to get warm, signifying that the thermostat did open up and we had a full circulation. I do have warm air coming out of the heater vents now, and I ended up having to top up the expansion tank one more time. One helpful thing was loosening the bleed screw on top of the hard line a few times. Just a little bit of bubbling comes out, and you know that there's a bit of air trapped in the top part of this line here. That seemed to help, and now things are looking good. A bit of a step backwards here. That noise that I couldn't figure out where it was or what it was, I wasn't happy leaving it, especially because it was coming from the front, and nothing notable was happening around the accessory belt level, so I went one deeper back to the timing. And what I've found is this upper idler has some stuff on the outside of it, but on the inside, all the lubricant that I assume was behind the seal has leaked out, and I think it's leaking a little bit onto the belt as well. So I'm going to replace that. I'm not exactly sure if this is what's going wrong, but I don't like that. My check engine light's also gone, which is perfect. I expect the remaining errors that you're seeing on the dash here to go away once I get my headlights and front bumper back on. And when the car's back on the ground, I'll be doing another scan with my Rostec VCDS just to show my clean bill of health. Finally, my official moment of pride. Back with a fresh scan on the VCDS in the engine section. No fault code found. I just grabbed a sample of the coolant out of the expansion tank, and I can see that my 50-50 mixture here is pretty much bang on what I thought it would be for protection level based on the mixing table. And just taking a second to see how far we've come, some of the water content out of my samples evaporated while I was waiting for extra parts to come in, but it's really cool to see the progress. I've got the car back on the ground, everything's buttoned up, and the work is done. Wow, this has been a great project, and I'm proud of myself for actually getting everything done as well as I did. I hope this video saves you time, money, and from a bunch of headaches. If there's any one thing that I learned during this project was that it's worth trying to figure out who the OEM manufacturer of the parts that you need to replace are, because although I can't get over dealership prices, I can't deny that the quality of the OEM parts is what you really need. It is absolutely not worth going for those really cheap aftermarket parts. Thank you so much for watching, and if you found any value in this video, please do consider subscribing. I've got a bunch of new projects coming up, and I hope you join me. Thanks.